For this example, we are now going to expound a little more and formalize Bayes' theorem. So this example states, a group of students gathered for a rally on the quad at their university. A total of 30% of the students gathered were seniors, 20% were juniors, 22% were sophomores, and 28% were freshmen. If 55% of the seniors, 15% of the juniors, 60% of the sophomores, and 40% of the freshmen at the rally were female, what is the probability that a male student at the gathering was a senior? Now, when you think about it, this example is made up of 3 sentences. The first sentence here describes the scene. A group of students gathered for a rally on the quad at their university. The second sentence then breaks down the group that the first sentence introduced. So of course now what we could do is describe this second sentence visually with a tree diagram. So we'll do that. So what we have is we have these students at a rally. And of course they're broken up by their class. We have seniors. I'm going to make seniors SR. Juniors, I'll make juniors JR. Sophomores, I'll make SO. And then, of course, freshmen. And I'll make that FR. So this column right here represents the first outcome of who's at the rally. And then, of course, we have 30% were seniors. So I'm just going to put in 30% here. 20% were juniors, so I'll put in 20. 22% were sophomores, and 28% were freshmen. And of course, if we add these up, 30%, 20%, 22%, and 28%, that's going to come out to be 100%. That's everybody at the rally. Now, the third sentence then sets the tone for the probability by breaking down the individuals into another group of females and males. So we have females and males, or you could think of it as females and not females, right? But females and males. And we haven't analyzed anything yet. We're just representing this scenario visually with a tree diagram. We really haven't done anything. For the seniors, 55% of the seniors are female, so I'll put in 55%. If 55% were female, then 45% were male. 15% of the juniors are female. That, of course, means that 85% were male. 60% of the sophomores were female, 40% male, and 40% female for the freshmen, 60% male. So here is our 3 sentences broken down into this tree diagram. So now what Bayes' theorem says, it says that the probability of A given B, that's going to be equal to the probability of A times the probability of B given A divided by the probability of B. So for this, what is the probability that a male student at the gathering was a senior? So we have to be able to determine all the males. So this is going to be the probability of a senior given that they're male. That's going to be the probability that they're a senior times the probability that they're a male given that they're a senior divided by the probability that they're male. So what does that all mean? Well, this is the group that we want to find. What's the probability that they're a senior given that they're male? So we're going to find each one of these here for the males, because that's what we're concerned with. So 30% times 45%. That is 13.5%. So here we have 20% times 85%, 17%. Here we have our 22%, and all I'm doing is I'm taking the probability of being a sophomore and then the probability of being a male, given that you're a sophomore, times our 40%, and that's what I'm doing for each one of these. That's 8.8%, and then of course 28% times the 60%. That's 16.8%. So this is the probability of being a male here, or here, or here, or here. So then if that's the probability of being a male, we're going to add all that up. Don't forget we're saying or. You could be this one, or you can be this one, or you can be this one, or you could be this one. So we'll take our 0.135, add that to the 0.17, add that to the 0.088, and then of course add that to the 0.168. And of course the group that we're concerned with is this group here. So then I divide this by the 0.135. And here's a tip. One of these values in the denominator will always be a value in the numerator. But if we look here, the probability of being a senior given you're a male, so given you're a male, we had to determine all the males. So then what this is equal to, that's the probability of being a senior, that's this right here, times the probability of being a male given you're a senior, that's this right here. So 0.3 times the 0.45, that's this right here, divided by the probability of being a male, which is all of these, which is what we put right here. And the probability of that occurring is 24.06%.